Hey everyone, welcome back. Today we're diving into a fascinating corner of gaming. History, the phenomenon of code rot, and a game that truly embodies it. Remember Escape the McRonalds? It was a unique experience, a game that captured imaginations for a while. But like many digital creations, time and technical shifts led to its unfortunate shutdown. It's a real shame when these digital worlds disappear, isn't it? The good news is, thanks to the dedication of other creators, Escape the McDonald's has found a new life. I'm excited to share with you the story behind its original closure and how it was brought back. We'll explore what code rot really means in the context of gaming and why preserving these digital artifacts is so important. Join me as we uncover this intriguing tale of digital preservation and the enduring spirit of gaming. Thanks for watching. If you enjoyed this, consider following for more deep dives into gaming's past. Hey everyone, welcome back. Today, we're diving deep into something that's been on my mind, and frankly, a bit of a passion project for me. We're going to explore a game that, well, let's just say it has some interesting code. And because we've got a lot to unpack, I'm going to have to pick up the pace a little. We're talking about hours of exploration and analysis, and I want to get to the heart of what makes this game tick, or perhaps what makes it stumble. So imagine this. You boot up a game, you're excited, you're ready for an adventure. You start playing and things feel off, not necessarily in a way that ruins the fun immediately, but there's a subtle undercurrent of something not quite right. This is where my journey began with this particular title. I decided to really dig in, to go beyond the surface-level gameplay and understand the mechanics, the systems, and yes, the code that underpins it all. And what I found was fascinating, to say the least. Now, I want to be clear from the outset. This isn't about tearing down a game for the sake of it. It's about understanding the craft, the engineering, and the challenges that go into creating interactive experiences. Sometimes even with the best intentions, things can get tangled, and that's precisely what we're going to explore. My initial hours were spent just playing, experiencing the game as intended. I was looking for those moments of brilliance, those clever design choices that make a game truly memorable. But as I progressed, certain patterns started to emerge. Little quirks, unexpected behaviors, things that made me pause and think, why is it doing that? This curiosity is what led me down the rabbit hole of code analysis. When I talk about code rotten, I'm not using that term lightly, and I'm certainly not trying to be overly dramatic. It's more of an analogy for a code base that has become difficult to manage, to extend, or even to understand, often due to a combination of factors that accumulate over time. Think of it like a house that's had many renovations. Some good, some not so good, and over the years, the wiring gets a bit messy. The plumbing starts to leak in odd places, and it becomes a real challenge to figure out what connects to what. One of the first areas I noticed this was in the game's asset management. Loading times, for instance, were a bit longer than I expected, and sometimes textures would pop in a little late, or animations would stutter momentarily. When you start to look at the underlying code, you can often see how assets are being loaded, how they're being stored in memory, and how they're being accessed by the game engine. In this case, it appeared that the system for managing these assets was, shall we say, less than optimal. There were instances where the same assets were being loaded multiple times, or where the loading process wasn't as efficient as it could be, leading to those noticeable delays and visual hiccups. Then there's the AI. Now, AI in games is a complex beast. It needs to be responsive, believable, and challenging without being unfair. In this game, I observed some rather peculiar AI behaviors. Enemies would sometimes get stuck in loops, or they'd react to stimuli in ways that didn't make much sense. When you trace this back to the code, you often find that the decision-making processes for the AI are either overly simplistic, or they've become so convoluted that they're difficult to debug and refine. It's like having a set of instructions that are so long and contradictory that the AI can't figure out what to do half the time. Another area that stood out was the game's physics engine. While it generally worked, there were moments where objects would behave in ways that defied logic. Things would fly off at impossible angles, or characters would clip through geometry in unexpected ways. This often points to issues with how the physics calculations are being performed, or how collisions are being detected and resolved. Sometimes, a code base can become so intertwined that a small change in one area can have unintended ripple effects in another, leading to these kinds of physics anomalies. The way the game handles player input and character movement also presented some interesting challenges. There were times when the controls felt a little unresponsive, or when character animations didn't quite sync up with the player's actions. This can be a sign of inefficient input processing, or a disconnect between the input layer and the animation system. In a well-structured codebase, these systems are designed to work in harmony, with clear communication channels. When those channels become muddied, you start to see these kinds of discrepancies. And let's talk about the save system. This is something that can be incredibly frustrating for players if it's not implemented robustly. I encountered a few instances where my progress wasn't saved correctly, or where save files became corrupted. This is a critical component of any game, and when it's not handled with care, it can lead to a lot of player disappointment. Looking at the code for the save system, I saw evidence of a rather ad hoc approach, where data was being written and read in a way that was prone to errors. What I'm trying to illustrate here is that code rotten isn't necessarily about malicious intent or laziness. It's often a natural consequence of the development process, especially for larger projects that evolve over time. As new features are added, as bugs are patched, and as the team changes, the code base can become a complex tapestry. Without consistent refactoring, without rigorous code reviews, and without a strong architectural vision, it's easy for things to become difficult to manage. Think about it this way. When you're building a house, you start with a solid foundation and a clear blueprint. But if you keep adding rooms, changing layouts, and bringing in new contractors without updating the original plans, eventually, you're going to have a house that's hard to navigate and even harder to repair. The same principle applies to software development. The game in question, while it has its moments of enjoyment, clearly shows the signs of a codebase that has undergone significant evolution without sufficient attention to its underlying structure. This isn't to say the developers didn't try. It's more a testament to the inherent difficulty of managing complex software projects over extended periods. The key takeaway here for me is the importance of good software engineering practices. Things like modular design, clear separation of concerns, extensive testing, and regular refactoring are not just buzzwords. They are essential for creating robust, maintainable, and enjoyable software. When these practices are neglected, even the most ambitious and creative game ideas can be hampered by the very code that brings them to life. It's a fascinating intersection of creativity and engineering, and understanding these challenges helps us appreciate the immense effort that goes into making the games we love. It also highlights the importance of continuous learning and improvement within the development community. Thank you so much for joining me on this deep dive. I know we had to move through this pretty quickly, but I hope it gave you a clearer picture of what I mean when I talk about a game's code becoming, well, a bit of a challenge. It's a reminder that behind every great gaming experience, there's a complex world of code, and sometimes that world needs a little bit of tending. If you found this interesting, please consider following for more explorations like this. I really appreciate you watching.